Welcome to Staros Recovery channel. Today we're going to discuss the components you can find inside the computer power supply unit and the elements it's missing, and how to add the components that the manufacturer didn't use to make this PSU cheaper. We're going to talk about how reliable cheap Chinese power supply units are and find out why they fail and literally burn so often. We're going to show you how to troubleshoot possible issues, measure voltage under stress from connected devices consuming power and without them. Generally, it must be very interesting, so you're welcome to watch it. Have you removed important documents by mistake? Erased a memory card or a USB flash drive? Reinstalled Windows or formatted a hard disk but forgot to save important information? Rest assured, products by Staros Recovery will help you. Start the utility and select the disk your data was removed from. After the scan is over, it will show you the files it has found and you'll be able to save them. Just today, download and try for free any product you seek by following the link below. Today, we are repairing a 400-watt octet power supply unit. Rated for 400-watt, ATX form factor, 70% efficiency rating. It comes equipped with an 80mm fan, an active power factor correction feature, short circuit protection, but no voltage stabilization or overload protection. So, why did it fail? In this specific case, the owner saw the magic figure, 400 watt, and decided the wattage would be just fine for this computer. But it was not to be. As a result, the wires got melted. This is why it happened. The PSU sticker says it's rated for 400 watt, but it's not all the truth you should know about it. It's the total output, and the real amount of power such dirt cheap PSU can give you is about 250 watt at best. Modern computers draw most of the power they consume in the 12-volt rail. This is the rail that powers almost everything in your machine. If we have a closer look at the 12-volt 15 amps rail of this PSU and calculate it into watts, you will get the true 180 watt, which is a far cry from 400 or even 250. So my message is you should be very attentive when you look at the stickers of the PSU you're about to buy, so that you can see what is the amount of power it delivers in the 12-volt rail. Here is an example of a good quality 400-watt PSU, where output by rail is shown properly. You can see easily how much real power you get in the 12-volt rail. Summing up, the person who bought this unfortunate PSU was a bit wrong in their calculation, having paid for a device which is almost twice as weak than they expected. The power supply unit survived a short circuit under stress, and the wires are a little melted, and the next stage would be burning. Alright, let's try to get it started. I'll start it with an equivalent of load. We are using an improvised piece of equipment, but you can also do it with ready-made solutions from Chinese online stores. I'll leave the link in the description below. As for the load, you can be fine with the light bulb, 60 to 100 watt. To start the power supply unit and test it under stress, you will also need to find the power on or standby contact. You can see it in the main connector that delivers power to the motherboard, and the wire's color is green. To start the PSU, connect this contact to the black wire, the ground. You can do it with a paper clip or tweezers. Now I'll connect it to a power outlet and try switching it on. The red LED is on, which means the standby power is present. Check the reading. It says 5.09 volt, which is great. Let's start it. The power supply starts, the fan is working. Check the voltage readings for all rails. Surprisingly, but all figures are okay. Now let's try connecting additional load in the form of this light bulb, which is about 100 watt. Give it 5 volts, okay, it's glowing. Now 12 volts, okay, it's much brighter. Check the readings, the voltage is as advertised. Yes, the 12-volt rail dips a bit to 11.83 volts, but it falls within the permitted limits. Let's get back to reliability, or maybe it's better to say durability, of cheap Chinese PSUs. As you can see, the one we've got for testing is rather good. In spite of its melted wires, it does work properly. Let's take it apart and see what's inside to check the condition of its components. Take out these 4 screws, remove the top cover. Visually, I can't see any damage to the inside. The capacitors look fine and are not bulging. This power supply follows a typical design for ATX units. Through this connector, the input voltage comes to the circuit card, which is missing an input surge protector, but there is a place for soldering it. My conclusion is the protector was omitted by our Chinese friends to make the PSU cheaper. After that, voltage travels to the diode bridge, and one of the diodes here has excessive soldering alloy on it, which might be a result of overheating. Here are 2 storage capacitors, 470 microfarad each, and this is the minimal capacity for this kind of PSU. 2 semiconductor power keys on the heatsink, and the transistor of the multiple output standby voltage generator. Isolating transformer, standby transformer, and on the other heatsink, this is the low voltage part of the PSU. Schottky diodes, the choke coil for 5V and 12V rail, and a choke for the 3.3V rail, then the power cables and the power line for the cooling fan. I'll take out the circuit card to examine the quality of tracks and soldering, which looks alright, with a small trace of something, possibly remains of rosin or effects of careless cleaning. Now, the first thing to be replaced is the wires used to deliver power to other components of the computer, as these wires have melted, and remove excessive solder alloy. The bunch of wires meant to deliver power to the motherboard looks okay. Let's check the diodes in the rectifier bridge. The diodes are okay. Now we replaced the wires and added some upgrades to this PSU. 3 extra capacitors, 1500 microfarad each, as the stock 1000 microfarad capacitors were insufficient for the rated capacity of this PSU. We also added a choke and filtering capacitors for the input voltage of the 220V main. In the high voltage part, we also had to replace the stock capacitors with high-quality ones, 560 microfarad each, because testing the stock elements showed they were only 2 cheap Chinese capacitors, 250 microfarad each, instead of the 2 capacitors, 470 microfarad each, as recommended for such configurations. After all improvements, let's test the device. Connect load, input voltage 220V. The power on standby is OK. The red LED is on. Send the power in. The cooler fan is working. Voltage in 5V, 12V, 3.3V rails is present, which you can see as these green LEDs are glowing. I'll check the voltage for every rail. 5V rail, 5V, 12V rail, 11.97V, 3.3V rail, 3.38V. Now let's add some extra load, about 100W. In 5V rail, the lamp is glowing, protection doesn't react. In 12V rail, the lamp is shining, protection doesn't cut the power either. Check the readings of the rails under load. 12V rail dips down to 11.72V, 5V rail to 4.98V, 3V rail to 3.31V. All voltage readings under load are within the permitted range. We tested the PSU some more under load, it works steadily. So it's time to put all covers back. Don't forget to put a protective clip on the cables to avoid breakdown to chassis, which may occur when their installation is damaged. Run a final test for the PSU, add some load in the 5V and 12V rays, And here is one thing I'd like to draw your attention to when using a powerful incandescent light bulb as an equivalent of load. This bulb is a nonlinear element and its resistance changes as the filament becomes warmer. When it's cold, it has a very low resistance, for example 0.3 ohm. That's why when you connect it to a 12-volt rail as an equivalent of load, the overcurrent protection element responds. But if you warm the filament inside the bulb with lower voltage, for example 5 volt, and then connect the bulb to a 12-volt rail, the PSU protection will not respond, as the filament has been heated and its resistance has increased. Let's try measuring the filament's resistance right after you cut off the power supply. And it's a huge figure of more than 4 ohm. As the light bulb cools down, its resistance gets lower, and you will see about 0.2 ohm at room temperature. With cold bulb having a resistance of 0.2 ohm, the current impulse will be about 60 amps, which exceeds the permissible current for a 12-volt rail of an ATX power switching power supply unit. And in the light bulb, which has been warmed up, the 12-volt rail current will only be between 2 and 5 amps. Finally, this power supply unit is restored now, and it could still be used for some low-end PC. And that is all for now. Let's hope your repairs are always successful and your computers work without issues. We will certainly go back to this topic again to examine the design of power supply units in more detail and tell you how to select the proper power supply for your machine. In our next video, you will see how to upgrade a laptop and select a suitable model of a more powerful processor. So, to make sure you don't miss anything, subscribe and check the bell button. Don't forget to like this video, and good luck!